Hello all, welcome back to my YouTube channel all about VLSI. In this video, we are going to discuss about transfer types in AHB protocol. Now, what do you mean by this transfer type? So, in our previous discussions, we have seen the signal which is known as HTRANS. So, this HTRANS is output to our master. So, let me show that HTRANS signal. So, the HTRANS signal, basically it is the output for our master. Let me show that in the block diagram which we have discussed in our starting session. Yes, so this is your HTRANS signal which is output to your master, and this is input to your slave, and this is also an address and this is also a control signal. So this HTRANS is also a control signal which we have discussed previously in our sessions. Okay, now let us try to discuss this HTRANS signal more detail. What is this HTRANS signal? What do you mean by transfer type? Now, since HTRANS it is of 2 bits, this HTRANS it is of 2 bits. So we have basically 4 number of combinations that we already know: 0 0, 0 1, 1 0 and 1 1. So this HTRANS, if it is equal to 0 0, the master is going to provide this particular signal to the slave on the bus. Okay, so the master it is going to send this particular signal HTRANS. Okay, so whenever it is equal to 0 0, it has one functionality. Whenever this HTRANS signal is set to 0 1, it has one functionality. So depending upon the value of the HTRANS signal, the functionality is being decided. Now what is the functionality? Let us try to understand. Whenever your HTRANS is equal to 0 0, that means your master is idle. I will write down here: whenever your HTRANS is equal to 0 0, the master is said to be in idle condition. Now what do you mean by idle condition? That means indicating that no data transfer is required. So if the master doesn't want to participate in any kind of data transfer, then it is going to provide this HTRANS signal as 0 0. So a manager is using an idle transfer when it does not want to perform any data transfer, and the slave or the subordinate must also provide a 0 wait state okay response to the idle transfer, and the transfer must be ignored by the subordinate. Okay, so what is this response, what is this okay, that we will discuss, but the important point to be noted here is the subordinate is going to ignore the transfer. Whenever your HTRANS is equal to 0 0, that is whenever the master is idle, the slave will respond okay response, okay, that we will discuss, and after that slave is going to ignore that particular transfer. So this is your first case where this is nothing but your idle, that is master is idle. It doesn't want to communicate, or it doesn't want to participate in any kind of transfer. Okay. Next is 0 1, that is HTRANS is equal to 0 1, that means transfer type is busy. So here 0 1 means transfer type is busy. Now what do you mean by this busy transfer type? So the busy transfer type enables master to insert idle cycles. So like when we were discussing your weighted states, where the slave was inserting weighted states by making their H ready is equal to 0. In our previous video we have discussed this particular concept. If you haven't watched those videos, please rewatch them. So like that only, the master is also inserting the idle states, or you can say weighted states, okay, by asserting this HTRANS to 0 1. Okay, so if HTRANS is equal to 0 1, the slave will come to know that okay, the master is busy. So the slave will come to know that okay, the master is busy. Okay, so this is how you are going to tell the slave, this is how the master is going to tell the slave whether it is busy or it is idle. Okay, so the busy transfer enables master to insert idle cycles in the middle of a burst. Okay, this burst we will discuss, and this transfer type indicates that manager is continuing with a burst, but next transfer cannot take place immediately. This particular concept we will discuss when we were talking about burst. But for now what we need to understand is, if the master wants to insert an idle cycle, or if the master wants to tell the slave that it is busy with any other transfer, it is going to make this HTRANS to 0 1, so that it will come to know, the slave will come to know that master is busy, and subordinate must always provide a 0 wait state okay response to the busy transfer, and the transfer must be ignored by the subordinate. Okay, this we will discuss while we were discussing about response signaling. Okay, so just what is the important point to be noted here is, if the master wants to tell the slave if it is idle or it is not participating in any or if it don't want to participate in any data transfer, it is going to say that it is in idle. Okay, and coming to busy, it is going to say the slave that it is busy with some any other transaction, and the slave will come to know, okay, the master is busy, and the idle cycles will be included. Okay, and coming to next type of scenarios, 1 0 and 1 1. So 1 0 stands for non-sequential type of transfer, and 1 1 will stand for sequential type of transfer. This is very important to understand. This idle and busy, by the name also we can understand the master is idle, and coming to busy, the master is busy. By the name also we can understand. Now coming to this 1 0 and 1 1, non-sequential and sequential, this we need to understand them carefully. Now let us try to understand what do you mean by non-sequential and sequential. For example, this is our master and this is our slave. Let's say the master is performing a write operation. Let's say the master is performing a write operation. That means the data is being transferred from master to slave. Okay. Now the master has provided the address signal. Okay, and it has selected its particular slave if there are multiple slaves. Okay, and now let's say if the master wants to write 4 number of packets. Okay, let's say this is packet P1 and this is packet P2 and packet P3 and P4. So these are the 4 packets where the master wants to send it to the slave. Packet P1, P2, P3, P4. Now we have already discussed this many number of times that for each and every data packet which the master is sending to the slave, or for each and every data packet the master which it wants to read from the slave, an address will be associated with that particular data packet. This we have discussed it a number of times. Now in this particular operation, when the master is trying to write the data to the slave, that is, it is trying to send 4 number of packets. Okay, for each and every packet there will be address phase, data phase, that and all we have discussed in our previous sessions. That and all I am not going to discuss for now. Okay, now here for packet P1, a address will be associated, that is address A1, and for packet P2 a address will be associated with this, which is A2, and for packet P3 address, let's say address A3 is associated, and for packet P4 address A4 is being associated. Okay, now coming to this 4 addresses A1, A2, A3 and A4. Now so this address A1 is completely a random address, or it is a starting address. Okay, and random in the sense basically for any particular slave during the memory mapping we will be allocate a specific set of memories. A 1 KB boundary will be allocated for a particular slave. So in that particular addresses the starting address will be decided. Okay, so from that particular address memory we will be choosing a random starting address point. Okay, so this address is not associated with any other addresses. Okay, there is no relation. Random, why I am using this random? Because random in the sense this particular address is not associated with any previous addresses or any previous transaction addresses. This is completely new address. Okay, for example this address is 0, 8. Okay, so this is the address which is available. This is the starting address. Now coming to address A2, A3, A4, these are not independent addresses. So the address A1 is an independent address, and this is an independent address. Although it is an independent address, it is going to lie in the range of your address boundary. Okay, that address boundary, everything we are going to discuss when I am going to show it in the Vivado. Okay, how the address memory mapping is happening to this particular slaves, everything. Okay, so for now you just understand that there is a pool of addresses. There is a pool of addresses like this, and this pool of addresses 1 KB memory addresses, 1 KB set of addresses are given to this slave. Okay, this slave, and in this pool of addresses some address has been given to this, some address has been chosen, and this address is not related with any previous transaction addresses. Okay, there is no relationship between this address and any previous transaction addresses. Okay, now coming to address A2, A3, A4, these are not independent, these are not random. Okay, A2, A3, A4, these are all dependent addresses. These are all not independent, these are all dependent. Okay, for example Address A2 you cannot take randomly. Okay, if you want to send packet P2 and the address A2 which is associated with packet P2, you cannot take it randomly. Suppose you cannot take it 0C or you cannot take it 020. No, it is not possible. So there will be some relationship between your address A2 and your previous address, that is A1. So here there will be some relation. That relation we are going to discuss further. Okay, there will be relationship between your address A2 and address A1. Okay, I'm going to explain this one more time. The starting address in a particular transfer is not related to any other address, or it is not related to any previous transaction. It is just randomly taken from the pool of addresses, that is the 1 KB addresses which are available. From that only we have taken the starting address. Coming to the second address, that is A2, it is not a random address. There will be some relation between your address A2 and address A1. That relation we are going to see in our upcoming slides. And coming to address A3, this is also not taken randomly. This address A3 will have some relationship between your address A2, and address A4 will have some relationship between your address A3. So if you can see, the address A1 is completely new, or it is not dependent upon any other previous addresses. But coming to address A2, address A3, address A4 has some relationships with your previous addresses. So that's why these addresses are sequential in nature. Okay, so the transfer type, now why I'm discussing this all, because the transfer type for your first address will be in non-sequential. That is, it is not dependent upon any previous transaction addresses. Okay, so here also we have this. So it indicates a single transfer or the first transfer of a burst. So the address and control signals are unrelated to the previous transfer. Single transfers or on the bus are treated as bursts of length 1, and therefore transfer type is non-sequential. This we are going to discuss further in our sessions. Don't worry about this, just we need to focus upon this particular point. That is, it is going to indicate a single transfer or the first transfer of a burst. It is going to indicate a first transfer of a burst. This is a burst. Burst is nothing but sending multiple data packets. That is nothing but your burst. Okay, so the address and control signals are unrelated to the previous transfer. And coming to 1-1, it is sequential. The sequential in the sense, the remaining transfers in the burst are sequential and the address is related to the previous transfer. Just now we have discussed it, right? Yes. So let us try to understand this with an example so that the things will be more clear. And before going to discuss this example, let us try to have one more example. Let's say we have a master and we have a slave like this. Okay. Now we need to send 4 packets, 1, 2, 3, 4 to the slave. Okay. Now this first address will be completely random, and address A2 will have some dependency upon address A1, and address A3 will be dependent upon your address A2, and address A4 will have some dependency on address A3. Okay. Now 4 packets has been sent, so the burst has been completed since 4 transfers has been sent. Okay, so this is basically INCR4 or it may be RAP4 that we are going to discuss further. But what was our requirement? Our requirement was to send 4 number of packets. We have sent the 4 number of packets. The requirement has been fulfilled. Burst has completed, that is transfer has completed. Okay, now master wants to start one more new fresh transfer. Okay, in the new fresh transfer, let's say the master is going to send again 4 number of packets. Now this 4 number of packets, the starting address, it can be A1 or it can be A2 or it can be A3 or it can be any address. It is not dependent upon your A4. This particular packet P5 which we are sending in the second transfer, this is completely a new transfer. This packet, the address can be any address. It is not dependent upon your A4 address, that is your previous transaction address. But coming to the P6 packet address, that is this particular address is related and it has some relationship with your previous address, and the packet P7 address will have some relationship with your previous address. And what is that relationship that we are going to discuss in our further sessions. Okay, so this is how we are going to decide and please remember, for the very first address of a transaction, the address will be completely new and it is not related to any previous transactions. So that's why the transfer type of the first packet or the first transaction will be non-sequential, whereas coming to the second, third and so on transfer packets, the transfer type will be sequential. Okay, so this is how we are going to decide whether it is non-sequential or whether it is sequential. Now let us try to understand this with an example. For example, here we can see we are basically performing a read operation. Now basically here we are going to perform a read operation because your h write is equal to 0. In this particular cases, your h write was equal to 0. Okay, very good. Now we can see we need to send how many packets. Here in this particular example, it is INCR burst means it is undefined length burst. Basically it is, if it is INCR means it is undefined length. That is, we don't know how many packets we are going to send, how many packets the master it is going to read, because it is a read operation, right? So basically INCR means it is undefined length. That is the master, we don't know how many packets we are going to read. Okay, I'm going to explain this when we are going to discuss about burst. This particular concept we are going to discuss now. So if I want to read the first packet, okay, so this is my master and this is my slave. Okay, now the master wants to read the first packet. Okay, it don't know how many packets we are going to read. Okay, so first we are going to read the packet P1, and the address associated with this packet P1 is 20. It is represented in hexadecimal format. Now, so next in the T1 to T2 cycle, if we can observe that, and in the T0 to T1 cycle, the HTRANS, the transfer type is non-sequential. Why it is non-sequential? Because it is a first packet. Okay, so the first packet address is completely random and it is not related to any other transaction addresses. So that's why it is non-sequential. Now coming to next T1 to T2 cycle, we can see the master is asserting this busy signal. That means the master is busy with some other transaction, so that randomly it is just giving HTRANS as busy, so that the slave will come to know, okay, the master is busy with some other transaction. So if you can see, whenever the master is asserting busy, here we are not getting any data. Okay, here we are not getting any data because the master was busy. In T2 to T3 cycle, we can see the transfer type was sequential. That means this is a second address. First address was for the packet P1, and for the second packet P2 we are providing address 24, and you can see HTRANS is sequential, and the third address is 28 and the HTRANS is sequential. Okay, and so on, sequential. So for only the first address we are going to provide non-sequential, and from next onwards we are providing sequential, because it is a part of this particular transaction. It is a part of this particular transaction, and the second address onwards there will be some relationship between the previous addresses. Okay, now this is how we are going to decide what is the transfer type, whether it is sequential or whether it is non-sequential. Now let us try to understand what will be that relationship. So we are talking about there will be some relationship between the present address and the previous address, right? So what will be that particular relationship? So before going to discuss about that particular relationship, we need to understand one more concept, which is known as HSIZE. Now, what do you mean by this HSIZE? So this HSIZE is also output for our master. This is also output to master. So if your HSIZE is equal to 0, if your HSIZE is equal to 000, it means it is a byte, and if HSIZE is equal to 001, it means it is a half word, and if it is 010, it is word, and it is 011, double word, 4 word, and 8 word, so on. Okay, so depending upon your HSIZE, the size of the packet is being decided. So in up to now we have said that packet only, but we haven't decided what will be the length of the packet. We haven't told anywhere, just I have told the packet, I am sending packet, I am writing the packet, I am reading the packet, but anywhere I haven't told the size of the packet. What will be the size of the packet? So the size of the packet will be decided by the signal HSIZE. Okay, for example, now let us consider a master and a slave like this. Now let us consider a master and a slave like this. Okay, now let's say we need to send 4 number of packets from the master to slave. Okay, so this is packet P1, packet P2, packet P3 and packet P4. Okay, this is packet P1, P2, P3, P4. In this particular write transaction, I need to send 4 number of packets. Okay, so this is a burst operation which I am performing. Okay, since I am sending a more number of packets. Okay, so this is a burst operation. In a single transfer, I am sending 4 number of packets. Now, let's say the size of each packet, I will write down here, size of each packet is 1 byte. So size of each packet is 1 byte. That is, packet P1 is of 1 byte, packet P2 is of 1 byte, packet P3 of 1 byte, and packet P4 is of 1 byte. Now, how the master it is going to send the packet to the slave? Now, first it is going to associate an address to this particular packet P1. Now, this address will be completely random and it is not dependent upon any other previous addresses. Let's say this address is 20. Okay, so this is the address which I am giving to packet P1. So the packet P1 address is 20. Now, I need to send packet P2. After the address space and data space everything has happened, I need to send the packet P2. So for packet P2 also there will be address associated with it. Now, how to calculate the second address? So second address will be calculated by adding the size with the previous address, that is 1 plus 20, that means 21. And the address for packet P3 is decided by this particular address, previous address, plus the size, that is 22. And packet P4 will be 23. So this is how I am going to decide the address of each and every packet. So the address of the packet will be decided by the previous address plus the size of the packet. I will write down here, address of a packet will be decided by so this head size plays a role. This head size is playing a key role for finding out the address of the present packet. So this is how, and this is completely random. So this 20 is completely independent, or you can say random. Okay, and from P2 we are having a relation. See, so how you are getting the address for P2? We are getting the address of this particular P2 by adding 20 with this size, and the address for P3 we are getting by adding 21 with this particular size, and for P4 we are adding 22 plus 1. So you can see these are all sequential in nature. These are all sequential in nature. These are all sequential in nature. So this is how we are going to find out the address of each and every packet in a particular transaction. Now, what is the size of the data which has been transferred from master to slave? That is being calculated by adding all the sizes, that is 1 byte plus 1 byte plus 1 byte plus 1 byte. So total 4 bytes of data we are sending from master to slave. This is how we are establishing, or this is how we are going to calculate the address of the present packet. Okay, now let's try to understand with one more example. Let's say this is our master and this is our slave. Okay, now so let's say if we are sending again 4 packets, let us take this 4 packets. This is packet P1, packet P2 or P3, P4. Now here the head size is equal to 001. So 001 in the sense it is a half word, that is 2 bytes. It is nothing but 2 bytes. Now what is address of packet P1? Address of packet P1 will be a random address. Let's say it is 24. Now what is address of packet P2? Address of packet P2 will be the previous address plus 2 bytes, that is 24 plus 2, that is 26. And what is address of P3? P3 is nothing but 26 plus 2, which means 28. So this is how we are going to find out the address, and this is how we are going to allocate the addresses, and this is how we are going to bind the addresses with our respective packets. So in a particular burst operation, if we want to send multiple packets, this is how we are going to calculate the address of each and every packet. And what is the width of, what is the total amount of data which we are transferring here? So 2 into 4, that means total 8 bytes of data we are transferring here. So total 8 bytes of data we are transferring in this particular case.